Hello, everybody. Just a quick going over the study guide. I'll post some pictures of the notes too, but just to kind of explain what I'm going on here. So your midterm on Thursday, Friday, 20 multiple choice, and then one free response. The multiple choice will cover the following topics: normal distributions, this like review from semester one, binomial random variables, standard eight, sampling distributions, standard nine, confidence intervals for proportions, which is standard 10. We just finished covering that. The free response question will be on confidence intervals. Um, to identify a normal distribution problem, you want to look for the word normal, and you're kind of selecting a single individual. In sampling distributions, we use the normal distributions also, but you're selecting samples and looking at either proportions or averages, in which case you need to calculate the standard deviation yourself. And um, anytime you sample, as long as you have a big enough sample, it will become normal. And there's two different conditions. We'll talk about that in a little bit. But for this section, it's like you look for an individual being selected and normal in there. What is the standard normal curve? This is the Z curve. The mean is 0 and standard deviation is 1. The Z is really useful. It tells you how many standard deviations, and there are problems where you need to use that Z curve. Kind of lets you make sense of what's going on. A Z is a standardized score. It's the number of standard deviations. An observation is away from the mean. And the formula for the Z score, it's the observation X minus the mean divided by the standard deviation. The curve is bell-shaped. To find probabilities, you can find the Z score and use table A, or you can sketch and shade a curve, and then use the calculator, use normal CDF. If you're given a probability, this could look like an area, it could look like a percentage, it could say percentile. You should be using inverse norm. Just be careful, but most of the calculators just use, they just give you the area below. From some of the new calculators give you another option, but the other one is just there below. So binomial random variables, watch for counts. You're counting successes. There's a set number of trials N and a probability P. Kind of like repeating something. The common mistake I keep seeing again and again is people don't understand if you're like a single probability of an outcome, you do you know, like the successes over total. Binomial, you're doing this like a whole bunch of times, and those probabilities need to multiply. It is more complicated than just a single fraction because you're doing something again and again and again, which requires multiplication. Formulas are on the formula packet. There's a probability formula. So on the packet, on the front page, if you're looking for a probability, that's this one right here. It's complicated because, like I said, it's that repeated multiplication. Mean is pretty straightforward. A lot of times I've seen students use this in calculating the probability. This is not a probability. This is the average count of successes. And then here, this is the standard deviation, which is the average distance away we can expect observations to be from that average. If you were to do lots and lots of sets of trials. So like I said, for probabilities, that repeated multiplication really means that you'll need to multiply. If n is 20, you would need to multiply 20 probabilities together. And then you also have to look for those combinations, which is the coefficient that comes in front. So it's quite complicated, which is why we use the calculator. Binomial PDF is for equal to, binomial CDF is less than. So watch out for that. And it's not simple probabilities. You have to look for those repeated kind of events. Sampling distributions, a sample was taken and we're finding either a mean or proportion from that sample. And what a sampling distribution is, it's basically like what would happen if we took many, many samples, and then many, many statistics were calculated. So if we did it again and again and again, every time I've had you do like those dot activities, that's what I'm doing is generating sampling distributions. Sample statistics vary. You may not get the same statistic as your neighbor, but we're looking for patterns and overall patterns that happen in my sampling, in these like repeated sampling. The larger samples we have, the variability reduces. We have a shrink in standard deviation. The parameter is a population measure. Almost always this is unknown, and we're using data to like estimate this population measure. Um, the formulas, how do you know which formulas to use? You look for a mean or proportion, and you look for one sample or two. All of the sampling distributions formulas, they're on this second page. Population or proportions come first, means come second, and anytime you're sampling, you need to be using these. This is different than having a single observation where you just can use the normal curve. For sampling distributions, you've got to use those formulas to find the standard deviation because you have a reduction in standard deviation. Um, Sampling distributions, they all move towards the normal of the larger the samples. For proportions, we check to see our counts, n times p, n times 1 minus p, expected counts. Are these greater than 10? Twice for two samples. The means, we either need to know our underlying population is normal or n is greater than 30. The last thing is confidence intervals proportion. What is a confidence interval? It is an estimate. And it's not a point estimate. We add a margin of error on each side. So it's an interval estimate that I think something is between two values. The statistic is the sample value. The point, another word for that is point estimate. Those are the same thing. Margin of error is added and the amount added and subtracted. It's based on um, the critical value, the number of standard deviation times the standard deviation, standard error on either side of that point estimate. The critical value is the number of standard deviations, and the standard error is just an estimated standard deviation. What does it mean to be confident? If we took many samples and made many intervals, um, that's the percent we expect. That's the expected intervals we expect to catch the true amount. And to identify the problem, you look for the word estimate, and you're estimating a population from a sample. And we are 95% confident that the interval from blank to blank captures the true, fill in whatever is from your context. Phrases that you should not use, watch out for probability language. We are confident. It's not the probability that a parameter is in that true thing because it's the intervals that are moving, not the parameter. So be very careful. Use this sentence. Make sure you use the word confident. This is not a probability. Um, any language we use need to talk about samples that vary and not the parameter. So when you're looking at multiple choice questions, read for sample to sample, it can vary, but the population parameter is the one that's constant. So watch for that kind of definitive language in the response that a sample will always be. That one is one you should rule out. So that's what you want to be careful for in the multiple choice. How do you use an interval to look for evidence? You check to see, is the value in the interval? If it's no, that's evidence of a difference. If it's yes, then there is no evidence of a difference. Okay, for shape, what are the checks? The shape you're checking for normality. The center you're checking for randomness, and variability you're checking for independence, that's kind of like that 10%, the 10% rule, meaning that sample is less than 10%. All right, hopefully this helps.